What's going on? Welcome to another awesome video where I'll be showing you how you can use SolidWorks and 3D printing to create something awesome like this.
This bittersweet heat is suffocating. I'm waiting and always hesitating.
So this here is a GoPro gimbal. The idea of this is to actually stabilize a GoPro while you're busy filming. Let's turn it off quickly. Everything here is store-bought. Everything above that is 3D printed. As this is one that attaches just to a simple drone, there's no power source. So what I had to do is buy an external power source, a battery pack and a switch, and put it all together. But then you're left with this mess of wires, so a lovely handle complements it all and makes it easier to hold as you're busy using it. Now, most of these gimbals that you can buy on Amazon or wherever range up to $200. Total cost for this, $50. So this is perfect for your amateur filmmakers. So let's get into how I made the awesome handle for this gimbal. Yeah, so I messed up on that part. The resolution and the scale of my screen recording software for some reason wasn't working to great standards. What I'm going to do is I'm going to show you a feature. One of my favorite features in SolidWorks is the rollback feature. And I'm going to use this just to go through step by step how I built this handle. So let's get to it. Like I said before, the time-lapse didn't record too well. So as a replacement, I'm going to go through the feature tree and just go through and just explain all the little details that I put in and why it's there. This will also show off the amazingness of this rollback feature, which can allow you to go back and edit certain features that you might want to change without having to start again. So let's get up to the beginning. Before I made any body, I actually created 6 sketches with 3 planes, creating the overall shape. I then created 2 surface planes just to kind of get those flat pieces. I'm only going to be designing half of this and then mirroring it over. There's no point doing the same thing twice. So those 2 surface lofts created that shape. Throw in a little surface knit and it becomes an awesome little solid body which you can then edit. I then created half of the battery box in this body here. Now the reason why I did this way instead of just cutting away is because I needed to have these round edges on you, and I obviously could not achieve those round edges if the corners were poking out, making a hole on the surface. So I created it as a solid body and then I combined it, or subtracted it, and that made the cavity needed. I then made a couple more cavities for the wiring that I wanted, throwing down a nice little tube, and then I made a cavity for the switch to go. So this is still all one body. I then used the surface split to split the top from the bottom. I then began hacking away at the hole over here for the screw, but what I did is I did something very interesting and new. Inside here, as you can see, there's a bolt shape. This is for a hex bolt. So let's section this. I've got that set as transparent so that you can see it. And as you can see, there is a lovely little cavity there for a bolt. And what this is for is to embed a bolt. And now you're thinking, hang on, how are you going to insert that bolt if it's all completely enclosed? Well, what you can do with 3D printers is that you can set it up to pause at a specific height. Also depends on your slicer. So I'll be setting it to pause at 15 millimeters high, which is about over there, where I would then proceed to drop a bolt into this cavity and the printer would carry on and then close off the top, making this bolt embedded in there. This is great for attaching features like this. If you want to hide the nastiness that is the bolts and nuts and you want to keep it neat and clean, this is a very good way to do it. I will be doing this with the bottom as well. But as we go down, I just start finishing off and rounding off all the little details, adding in for the switch there, a nice little fillet over there to finish it off. And then finally, I would then mirror everything over. The only problem is that this is still 2 separate bodies, so all I did was use a combine. I made that one body. Now that keeps it at 3 bodies. I then used the body delete feature, which allowed me to just delete a certain body, and then I'd use this to save as an STL, which is perfect for printing. So that's how I made this model. Let's get on with the printing of this, the assembly of this, and then the awesome footage that I captured with this gimbal. With the pause setting, the printer will just carry on printing just like normal. Then it will stop printing, move to the side, and this is your opportunity to then insert the two little bolts. I've used a simple pair of pliers to drop them in there. And once complete, you press resume on the front of your printer, and it carries on from where it left off, enclosing the bolts into the body. So the few store-bought parts was a compatible battery, a GoPro gimbal, the GoPro was not included with this, a basic toggle switch or flip switch, and some nuts and bolts. So once all the parts were printed, all that was needed was to solder the switch onto the gimbal, and then connect on the plastic pieces. This is all attached with screws, no glue at all, as you need to open up to get the battery in order to charge it, so I decided to use screws to put it all together. All three pieces just fit together very simply, and once it's all connected, flick the switch and your gimbal is ready to gimbal. This is an awesome little project, especially for those amateur filmmakers out there who want to create stabilized videos for action sports at a cheap rate. Hi. So as you can see, it's completely stable and it works beautifully. I hope you learned something from this. This is an awesome project that can show you how you can take some components cheaply bought all over Amazon and put it together to make something that is actually worth about $200 if you were to buy it in a complete package. And this is the advantage that 3D printing can have, because without 3D printing, this handle wouldn't be able to be there and I'd have to hold it like this with a battery knocking about. If you guys have any questions about this gimbal or any projects like this, please leave them down in the comment section down below and I'll answer them to the best of my ability. We'll see you guys in the next one. Whoa, whoa, in my face, in the face, in the face. Whoa.